Hello students. So in this tutorial of TensorFlow, we are going to explore the possibilities with functional API. So till now we have explored the sequential API, right? And we have done some of the tutorials in CNN as well as in TensorFlow, how to build a model using sequential API for image data as well as your structured CSV or Excel format data, right? So text we haven't seen yet, so we'll explore that when we'll be dealing with Gen AI, LLMs in that space. And everything that then we'll cover. Okay, so what is the basic difference between sequential and functional API, right? So functional API gives you a lot more than what sequential probably provides you. Okay, we'll see that with this tutorial or hands-on, right? So how you probably write functional APIs, right? So let's say you are going to define a model, right? That's we have implemented same thing right here. Okay, so how you are going to call, you have ta dot, then you have to call keras. From keras, let's say you have to call the models, and then from models you are going to call the sequential, right? So and within sequential it will create the bracket, and once this bracket is created or the assembler is created, then within this assembler sequential assembly you are providing all the layers, right? Let's say for convolution neural network you are providing the convolutional layers, then max pool layers, probably batch normalization, then again convolution, one or two more convolutions, then flattening it out with linear network, and then your final output. Okay, so the same thing we can also implement using functional APIs, right? So this is understood, right? This portion. So this is our old sequential API. So let's say we want to implement the same sequential API I mean, same model that we have implemented using sequential in, let's say, functional API. So how I can write it down? Okay, so first, for just creating another code cell, right? To create your functional API, okay, it's pretty much similar to your sequential API, but it has a lot of I mean, in Python if you have used functions, right, it's kind of same. So yeah, I'm going to accept that by using, okay. So you can see, so tf.keras.input. So previously what we were doing, tf.keras.models.sequential for first creation of this sequential class, and then stacking all the layers, right? But here in case of functional API, we are doing different. First, we are creating one input layer. Like think about the model, right? What will be go inside the model? First thing, it will take the input, right? So that's what we are defining here. The tf.keras.input will let you, I mean, explore the possibilities of, giving the input to the model. Okay, so once that is done, now next, what we used to do? Now we used to do flatten, right? So what is happening? Once this input we receive in sequential, if you see, we are calling this flatten method, right? So what this flatten method will do, it will just flatten the 2 by 2, I mean 28 cross 28 matrix, right, into a linear step. So same thing here we have to do. So yeah, let's just accept whatever code it is coming because it's mostly correct. So now we are calling the same tf.keras.layers.flatten, right? The same thing. Okay, but we are not now passing input shape equals to 28 28 by 28 basically in this format. So we are just calling the flatten function basically, and then we are passing this input layer as an argument kind of thing, right? Okay, so this is the syntax for stacking your functional APIs, right? So your new layer, okay, within that new layer, then you will pass the previous layer. This is the stacking method or principle, right? So your previous layer is nothing but your input layer. Okay, that is what we are passing at the very end of the flatten layer. So once the layer is flattened, then you can see we are calling one dense layer, right, of 128 neurons. So to implement that one, okay, so first dense, let's just accept, right, this code. So what is how we are defining? Same thing, right? tf.keras.layer.dense 128, activation is tf.nn.relu, right? Same thing, but once it is finished, we are just within a first bracket calling the previous layer. Okay, as we are not using the word sequential, right? It's a complete separate API calls, right? So I mean, it's basically functional API. And similarly, we are defining the output layer. Okay, so once this layer creation is ready, okay, let's say you're running all of this, your 4 layer creation is ready, right? Then how you will call? You will call model. Okay, so from where you are getting this model? You are getting this model from TensorFlow.keras. Okay, so from model module, okay, you are calling this model function. Okay, from Keras model you are calling a model function, and in the model you are providing the inputs and outputs. So what a model normally takes, let's say sequential model, right? It takes an input and provides the output. Same thing here also, you have to take the input and you have to provide the output, right? So our inputs will be nothing but this input layer, right? That will go in the input channel, and output, why it's not outputs, right? So the outputs argument will take my output layer, right? So once this is done, you can call it and your model creation is ready. Okay, so you can see, so your functional model is ready, right? So this is how you create a functional model, and it has a many advantage compared to, you know, your sequential model that we can see. With functional models, you know, basically we can build models with multi layer output, okay, multi output neural networks basically, where you will provide one input and you are expecting the same architecture with little bit modification. So let's say in after 3 layers it is predicting one output, then let's say after another 3 layers it is predicting another output, right? So in that fashion, single architecture will be available to detect or to classify or whatever problem statement you are dealing with, right? So you don't have to define different architecture for different problems, right? So that we will see a small example. So yeah, that's your how to build functional API, right? Models using functional API. So now if you plot the model, so you can definitely see this, right? Once the model is ready. So what our previous method is, we used to call, right? So let's say I'm just utilizing this one, this code of this. So let's say I have my model stored in this model object, and I am calling model dot summary, right? So you can see, right, the same thing. So I have input layer, then I have my flatten layer, then I have my dense layer, then I have another dense layer, right? And these are the parameters, these are the trainable, non-trainable parameters, all the details. And same thing, okay, we can see if now, let's say I'm taking it as model 1 and I'm passing my sequential model, right, as okay. So now what I have to do, again, to call this model summary. If you call this model, again you will see same thing you are getting, right? The architecture is pretty much same, right? Directly now here you are getting the flatten layer, right, with 0 param, it is learning. Then you are getting one dense layer with 128 nodes, right, where your trainable parameter is 1 lakh 480, and you have 10 levels output, right? So similar kind of architecture you are getting, only the printing statement is kind of different, right? So this is the advantage of functional layer, is that you can segregate these steps. Okay, now to more appealing visualization, if you want to print any model, will be using this plot model graph. So this plot model graph we need to import from the utilities of Keras. Okay, so we have already imported that. So you just pass your model, then you just make the shapes that you wanted to see the shapes, then also the layer names, and you just provide one file name so that it can store the model, and that's it, right? You can see, so it's a much better visualization of your model. So here you can see whatever you have built, right? 128 cross 28 image will be your input layer, and in this when this image is getting inputted, what will be my output shape? Nothing, right? It will be similar to 28 cross 28, right? So once this is going to fade into this flatten layer, then what it will do, it will take this 2D or 2D array as input. That means 28 cross 28, and in return it will provide you 784 linear stack, right? Once this linear stack you will get, then this dense, where you will get this one as input, this one is output. So by this way it is much more understandable, right? And it also gives you a good understanding of the architecture of the neural network, right? And this is the code for training and simple fashion MNIST, right? So you can try it later when you have this notebook access, right? So I'm not running this. So let's just directly go to the capabilities of this functional API, right? Where we are going to build one multi-output model. So what is multi-output model? Normally in this kind of cases, right? In this kind of models, what is happening? You are providing one single output, you are getting one you are providing one single input, and you are getting one single output, right? But in case of multi-output, what will happen? You will have more than one output, right? And that's it. So how to build one multi-output module? We'll see that with a very simple data set provided by this UCI education labs, right? So if you go to this website, right, it will directly bring the data, I guess. Still, let's just check. Yes. So how you can see, just go in this data set. Okay. Enter into this folder. Let's just try. Oops. Anyways, so this is the your URL for downloading the data set. It contains 4 to 5 features, and it contains 2 outputs. Okay, that will be helpful for your multi-output functional API or multi-output model building. So what we'll go step by step. So we'll just load this URL using pd.xl, right? And then we'll just sample the whole data set. So once that is done, let's just visualize some of the datas. Okay, so you can see we have x1 to x8 as our input data, our features, and we have y1 and y2. These two will be our target levels, right? So with normal machine learning, it is pretty much difficult, right? Or you have to build normally 2 models for prediction of y1 and y2 using this x1 to x8 features, right? But with multi-model functional API, right, you can build a single model, single architecture within which you can predict both y1 and y2, that we are going to see. So EDA or data visualization is not part of this tutorial, so we are skipping that portion, right? So let's say we have this data, and this data is what we are going to fed into the model after doing all the normalization, not normalization, basically feature selection and all the other preliminary steps, right, or the EDA steps. So just we are going to import the train test split, right, because we have the whole data set where we have to split the data. So let's say 80% training and 20% testing. So the code, let's just do that. Okay, and let's just describe, store the descriptions in train states, right? So what this variable will output is nothing but the output of this describe function, right? That means all the statistical measure of this data set, right, where we have from x1 to x8 and y1 to y2. So yeah, you can see it's only a 600, I think 614 data points are there, so the training will not take much time, right? So once we have this data, let's just from this stat, right, let's just pop y1 and y2. Okay, so why we wanted to pop all these two? So we wanted to uh, take these two as an array, right? These two values. Okay, and then what we can do, we can, whatever left is there, whatever remaining structure is there, right, from x1 to x8. So now if you print this train stat, what you will get, you will get all the values rather than y1 and y2, right? Because you have popped out all these two columns basically, right? So now if you do a transpose, okay, train stat dot transpose, so you will get the same value of your describe method, what it used to provide, but in a transported manner, in a manner where we can utilize all these details. Okay, now same thing, how we need to now format, okay, the outputs. Okay, so how we are going to format the output? First, what you have to do, you have to copy it from the data. Okay, that means, let's say you have a df is your database, right? Just calling all of this. Okay, and just going to print y1 and y2. So it will not be much huge because both contains only 600 records, right? So 1200 records are there. So you can see these will be the values, right? This will be the printed values of y1 and y2 that we got, and this is the required output. Okay, and how you are going to basically format your training, that we'll see later, right? So in case of training, what we required, we need to, if you see here, your x1, x2, x3, x4, x5, x6, x7, x8, right? All these values, right? All these values are numerical basically. So we can normalize every feature here because all are numerical, right? So we can utilize this mean and standard deviation, right, of these features. So from here you can definitely get the standard deviation and mean of all this feature. So we'll just simply do normalization. So it's the same thing we are doing in this norm function. We are just returning the feature. We're just subtracting the mean and then we're dividing with standard deviation for doing a normalization. And then we are just creating our training and testing data with normalized values. And we have also stored our outputs, whatever required outputs like train and test, in array format here, right? So this is the overall code block that explains the basic preliminary steps you need to perform before doing any machine learning or deep learning, right? Provided you have all the data correctly in your workspace. So let's just run this cell. So it will rerun everything, and now we have our normalized train data set ready. We have our normalized test data set ready. We have our outputs y1 and y2 ready, right? Now again, the task here is to build one multi-output model using functional API, right? So what we have to define, first we have to define the input layer. So we are defining the input layer as input, as we have seen, right? So previously we have to use this tf dot where it is here, right? So previously what we have used this tf dot keras dot input, right? and now we are just directly calling this input, because from layers we are just importing dense and input directly, right? So calling this input function and providing the shape of the data. So our data shape will be whatever the length of number of columns available in the training data set, right? So this train dot columns and length of that will be our one shape, and we don't care about the number of details, right? That will come as batch. And second, again providing one dense layer in the first layer. That's our first hidden layer, where we are providing 128 nodes of hidden units. We are using ReLU activation, and we are passing input layer. Then again definition of your second hidden layer, where we are again calling this dense function. Basically for creation of dense layer, we are passing 128 hidden nodes with ReLU activation, and we are calling this first dense layer as the input to this second layer, right? And once this is done, we are just calling the output layer of the first prediction, okay, the y1. So we are calling the dense layer, where we'll be requiring only one unit, that will be the output unit. So let's name it as y1 output, okay, and we are just passing the second dense, right? And at the same time we are creating another dense layer, where we are creating this layer with 64 nodes, 64 hidden units with ReLU activation for prediction of second output. And once this hidden layer is created, then we are calling this second output, where we are similar to this y1 output, right? We are defining this y2 output. So now once we have all the outputs, right, that means we have one input and two output with us, right? This is one output, this is one output. So in the model API, what we are calling, we are providing the inputs as only one input, right? It's only one input, but in output section we are providing two outputs as list, right? Okay, so now I have two outputs instead of one output, and then you can print the model summary. So if you run this, you will see a structure like this, where you have an input like this, then you have first hidden layer, then you have second hidden layer, okay, and it is also showing where this layer is connected to. So this hidden layer is connected to the input layer, then this one is connected to this layer, okay, and then again you have another hidden layer, right? So this hidden layer 15 or 15, right, with this 64, it is also connected to the second hidden layer. Now your first output is connected to dense 14, right, if you see, and not 15, right, because we have defined this first output after two hidden layers, right, after these two. So that is what it is showing, and in the final output it is as usual connected with the last hidden layer, right? So dense 15. So this is the overall architecture. So you can also implement the same for better visualization, right, that we have already discussed. This plot model, let's just copy this. So let's import, let's just paste shapes and okay. So you can see in model section, okay, it comes pretty wide. So this is our input layer, then we have our first dense layer, then we have our second dense layer, then we have another dense layer as our hidden layer, and our first output layer, right? And then we have our second output layer. So this is how your model architecture is with this two output prediction neural network, right? So once this is defined, as you know, for training we require two things. First one is our loss function, and second one is our optimizer, right? So we are just providing ADA grade optimizer here from optimizers module, and in loss for y1 and y2 we are providing MSE as losses, right? And in metrics, that means in model compilation output, let's say we are providing just share me the root mean square errors, right? So once your compilation is ready, you can call the fit method and you can pass the training details. Okay, and let's say for 500 epochs we want to train, and in validation data you can pass the testing data, as we have less number of data, right? We have only 600 data points. So I have already pre-trained this, right? So once this training is done, okay, so you can see we'll get three outputs from evaluate function. First one is the loss function. Okay, this loss will be the combined loss. Then we'll get y1 loss, and y2 loss is nothing but this y1 RMSE, y2 RMSE, right? So if you can print, you can see this is the total loss function. Okay, the loss for y1 and loss for y2, and if we just sum, do a square and sum, you will get this same output of your total loss, right? Because for y1 y2 you are printing the RMSE, and for total loss you are printing the loss, right, which is nothing but the summation of first loss and second loss, right? So yeah, that's it. So you can see how easy it is with the functional API to build multi-output neural network. Okay, and these are some boilerplate codes, right? Once you have this model trained and predicted, so for further evaluation and stuff, you can plot the differences between the prediction and actual values, right? So you can see the true values and predictions. Okay, once we have tested, I think we need to train it again. I think it is taking some different values. Okay, and then you can also plot the matrix. So I have already plotted for you, so you can also see the how your RMSE is changing. Okay, so this is for validation and this is for your training. So the green line is for validation and the blue line is for your training basically learning curve, and you can see with every epoch how your loss is decreasing. Okay, now this is the basic implementation for this tutorial, that means functional API and multi-output network building. Now the similar same approach we can also implement using PyTorch. So as it's a TensorFlow tutorial, I'm just only giving you the boilerplate codes how to define. So first, similar thing, right? You all have to call this torch.tensor to make all the values basically your input values to tensor. Okay, once this is done, you will just create one train X tensor and the output tensors. So this is my input train tensor, this will be my output tensors, and similar for my testing data. Once these are done, we are calling data loader. We're just creating the data set basically. Okay, so first we are creating the data set, and then on top of this data set we are calling the data loader. So once our data is ready, we are just creating the model. So here also similar, first we are creating one linear stack with input dimension and 128 hidden output, and then again 128 128, then again 128 664, then our first linear network with 128 and that means with self dense 2 and linear output, this one, and then again the final output is with dense 3 and output, right? And then in forward method we are implementing the calling functionality, so just applying ReLU non-linearity where it requires, and just calling this output. So yeah, and then we are just printing the model, and then here same thing as we have mentioned there also, right? We are implementing ADA grade as optimizer, MSE as loss criteria, and for 500 epochs we are doing this training. So similar thing we are doing in PyTorch, and once that is done, we are just calculating the test loss, and once the loss is ready, we are just printing predicted versus true values, and you can see it's mostly accurate, right? And then we are just printing the training loss versus validation loss here, the similar code that we have seen in TensorFlow, right? So that's it for this tutorial, where we have seen how to implement multi-output dimensional model using functional API. What are the benefits of functional API in TensorFlow, how to implement completely from scratch. So I hope you have watched this video, have understood the functional API basics, So in the next tutorial, we'll be coming with lots of more new tutorials and understanding concept understanding videos of machine learning, deep learning, artificial intelligence. For that, stay tuned with us. Okay, thank you.